Hi everyone, and welcome to the last video in our WCRL Getting Started series, the 3D Printing and Assembly Guide. I'm Sam, and in this video we'll go over how to 3D print and assemble your bot. In addition to this video, we also have the Getting Started video, Design Guide, and Electronics and Coding with Arduino Guide. We plan on adding more videos, like a guide for using the Raspberry Pi Pico, in the future. We recommend watching the whole series before starting your bot. Let's first go over the basics of 3D printing for WCRL. The two most common types of 3D printing are FDM and SLA. With FDM printing, filament is heated and extruded layer by layer to create a part. This type of printing is most common for WCRL, as there are a wide range of filaments you can use with differing mechanical properties. SLA printing uses a laser to cure liquid resin, which can create a highly detailed and smooth part. However, resin is more brittle than many of the FDM filaments, and so it's not recommended for WCRL. There are a few materials commonly used for WCRL parts. PLA is the most common, as it is a rigid material with a high tensile strength. ABS is impact resistant and has a low density, meaning it can help you cut down on weight if you're close to the 1 kilogram weight limit. PETG is also impact resistant and is easier to print than ABS, and it has a higher tensile strength but lower compressive strength. TPU is a cool material because it's very flexible, making it a durable option since it absorbs impact instead of breaking. If you're not sure what to use, starting with PLA for most parts is the safest option. WCRL is looking to expand our support for different materials, so let us know if you're interested in trying something new. The main setting you need to worry about for your parts is infill, which is the amount and structure of material that will be on the inside of your part. For your first few prototypes, use a small infill density of 5 to 10%. You'll almost definitely find some things you want to improve on or have parts that won't fit right, so it's pointless to waste material on an early prototype that won't be used in combat. When you're fully confident in your design and fit, we recommend printing the chassis at 20 to 25% infill, as it's extremely rare that your opponent's weapon will go through the chassis and physically damage the internals. For smaller, exposed outside attachments, go with 30 to 40% infill for the added strength. Your competition attachment will probably be the part that takes the most impact, and having more mass on it is usually beneficial. So we recommend 60 to 80% infill for these. Using 5 vertical shells on your prints also helps strengthen the outside of your part. As for the infill type, gyroid provides equal tensile strength in all directions, while honeycomb takes longer than average to print but has the most strength. Cubic infill is also fairly strong and prints quickly. Avoid using really high infill for all your parts, as that will add unnecessary weight. Besides, bots often lose because of unreliable electronics, design flaws, or weak assembly, rather than the material itself failing. There are a couple different ways to get parts printed on campus. The ETS offers free printing for WCRL parts, and it's located on the first floor of the Technology Hub, which is in between the Union and the library. They will take care of setting the print up, so you just need to stop by to give them the STL file and tell them the settings that you want. WCRL also has a Prusa Mini for competitors to use to print smaller parts, and some eBoard members can print parts using their own printers if you ask them. The Fab Lab also has a few printers for which you can contact the shop techs to get parts printed. Tolerancing is an important part of 3D printing, and it's difficult to get right on your first prototype. Say you have a pin which you want to fit tightly inside a hole on the chassis. How much bigger should the hole be than the pin? These fits from the ETS can serve as a guide for your design. If you want a tight fit, make the difference in size 0.127 millimeters or 5 thou. From my experience, even if you want parts to fit tightly, this is usually too tight to assemble easily. A normal fit is 0.254 millimeters or 1/100th of an inch. This is what I would use for the pin and hole example. If you want a loose fit between parts, make the size difference 0.508 millimeters or 2/100ths of an inch. Note that these fits may not work exactly how you want them, depending on the type of mate and the size of the parts. Use these fits as a baseline for your first prototype, and then adjust the sizing as needed when you print your later versions. When you're ready to assemble your bot, WCRL and the Fab Lab have most of the hardware and tools you'll need. For screws and other hardware, you can use the WCRL bins in the Fab Lab or the hardware bins in the back left corner of the machine shop. Remember that the WCRL rules say that all fasteners may only be used for their intended purpose. Threaded inserts, which we covered in the design guide, can also be found in the WCRL bins. The Fab Lab has screwdrivers, soldering irons, a drill, and more that you can use to assemble your bot. When you're assembling your first few prototypes, it's common for parts to not fit correctly. You may need to drill some holes, sand down parts, or make cuts with a rotary tool. Give yourself plenty of time before a competition to assemble your bot, because you don't want to be dealing with these unexpected issues 30 minutes before the competition starts. This wraps up our WCRL Getting Started series. If you have any questions or recommendations for the series, email wcrl@binghamton.edu. Thanks for watching.